Welcome back to our channel, Digital Future AI School. We're so glad to have you with us. Before we jump in, if you enjoy what we're doing here, please take a moment to subscribe to our channel and like and share this with your friends. It really helps us out. All right, so this is episode 4, and we're diving into chapter 4 of the book AI, Your Smartest Partner in Life and Work by Mr. Zahir Ahmed Mir. Today, we're tackling a massive question. How do machines actually learn?
Okay, let's just dive right into this, because this question, it gets to the absolute core of what makes modern AI so incredibly revolutionary. The answer is what separates an AI from literally every other piece of software that's ever been created. You see, it's not about just following a pre-written set of instructions anymore. It's about creating understanding basically from scratch. So to really get a handle on how AI learns, we first need to understand its teacher. And here's a spoiler for you. It's not a team of programmers sitting in a dark room meticulously coding every single rule. Nope. AI's teacher is something way bigger, way more chaotic, and honestly, way more powerful than that. What you're looking at here is a complete paradigm shift. I mean, a total game changer. With traditional software, humans had to think of everything. Every single if-then scenario had to be manually programmed in. But now, we have systems that we don't really program in the old sense. Instead, we train them. We just give them the examples and somehow they figure out the how all on their own. It's pretty mind-blowing.
So what is this secret teacher? Well, it all boils down to one single powerful thing: data. We're talking about massive, sprawling, unbelievable amounts of data. You see, an AI doesn't learn because someone told it, if you see this, then do that. It learns by swimming through a vast ocean of information and discovering the patterns, the connections, and the hidden structures all by itself.
And when we say data, we mean, well, just about everything humanity has ever digitized. We're talking about the text from millions and millions of books and websites. Every picture, every video, yep, including all the cat videos. It's scientific data, conversations, the very code that builds our software, and even the subtle patterns in how we all behave. The AI just soaks it all in to build its own understanding of the world.
Okay, so you've got this mountain of raw data. The big question is, how does a machine turn all of that into something that even looks like understanding? Well, the answer comes from a piece of engineering that's inspired by the most complex object we know of in the entire universe: our own brain. This right here is the engine room of modern AI. It's called a neural network. Now, of course, it's not a physical, squishy brain in a jar. It's actually a really complex mathematical system made up of millions or even billions of tiny digital neurons. Each one is basically a simple little calculator, but when you link them all together, they can do some incredible heavy lifting.
And what's wild is that each individual neuron is actually super simple. It really only does 3 things. It receives some information, it does a little bit of math to decide how important that information is, and then it passes its result on to the next neuron in the chain. It's a tiny, tiny step. But the chain reaction of billions of these tiny steps happening all at once is what lets the system recognize a face in a crowd or understand the meaning of a sentence.
And here's the really crucial part. When you stack lots and lots of these layers of neurons on top of each other, the network can learn more and more complex things. So the first layer might just see basic stuff like lines and colors. The next layer might combine those into shapes like an eye or a nose. And a layer deeper than that might recognize a whole face. This stacking of layers is what we call deep learning, and it's the powerhouse behind almost every big AI breakthrough you've heard about recently.
All right, so we've got our fuel, which is the data, and we've got our engine, the neural network. But how does the actual learning happen? Well, the principle is amazingly simple because it's exactly how all of us learned when we were kids.
Just think about it. How would you teach a toddler to know what a dog is? You're not going to sit them down for a biology lecture, right? You're not going to give them a long list of rules to memorize.
You don't get into the specifics of whisker length or the exact curvature of a tail or the frequency of a bark versus a meow. Of course not. You just show them examples. You point to a picture and say, that's a dog, and you point to another and say, that's a cat.
And then, almost like it's magic, after seeing enough examples, their brain just gets it. It starts to build its own internal set of rules. It figures out the patterns that make a dog, without ever being explicitly told what those rules are.
And believe it or not, that is exactly how an AI learns. It's doing the very same thing a child does, just on a scale that is completely impossible for a human brain. It looks through millions of examples and automatically figures out the patterns that define, well, anything. This is what makes AI so unbelievably flexible. You can point it at almost any kind of data, and it will learn the patterns. Show it billions of sentences from the internet, and it starts to learn grammar and language. Show it thousands of medical scans, and it learns to spot the tiny patterns that might signal a disease. It learns strategy by watching chess games, and it learns meaning by reading pretty much everything ever written.
Okay, so let's tie all of this together. We've seen that AI learns from data, it uses these things called neural networks, and it finds patterns just like a child does. So what? Why is this simple idea so incredibly powerful? What's the big takeaway here? This quote from the book really just says it all. AI extracts rules without humans writing them. I mean, just let that sink in for a second. This is the whole revolution in a nutshell. For the first time ever, we've built systems that don't just follow our rules, they actually discover their own rules, rules that were hidden deep inside the data of our world.
And hey, don't for a second think this is some kind of far-off science fiction technology. You are using this pattern matching power every single day. When your phone's photo app automatically finds every picture of your dog, that's it. That music app that just seems to know the exact song you want to hear next, that's it too. Even the spam filter that keeps your inbox clean, it's all powered by this ability to find patterns.
And that leaves us with one last really big thought to chew on. As these AI systems keep learning from all of human knowledge, our science, our art, our conversations, everything, what new rules, what incredible patterns, what amazing insights about our world and even about ourselves are they going to uncover next? We're just at the very beginning.
I mean, we see what it can do, right? But what's really happening under the hood? In this explainer, we're going to break it all down, piece by piece, into the fundamental building blocks that let a machine go from just lines of code to something that feels, well, intelligent.
And this is episode 4, where we're drawing from the incredible insights in the book AI, Your Smartest Partner in Life and Work by Mr. Zahir Ahmad Mir. We're going to use the core ideas from his work to build a really simple analogy so we can all see exactly what's going on inside the machine. Ready? Let's get started.
Okay, let's start with this right here. This very sentence you're reading. Now for your brain, this is easy, right? You process the words, the grammar, the meaning, all in an instant. But for a machine, that's a whole different ballgame. How does it possibly get from just a string of characters on a screen to actual genuine understanding? Well, that's the puzzle we're here to solve.
The very first step, the absolute foundation of it all, is something called a token. I want you to think about building an AI like you're building a house. If you're going to build a house, what's the first thing you need? Bricks. Tokens are the individual bricks of AI. You literally can't build anything without them. So what is a token really? It's just a small piece of text. It could be a whole word, maybe part of a word, or even just a piece of punctuation like a comma or a period. See, an AI doesn't see sentences the way that we do. It sees a long sequence of these little tokens. This is the real alphabet that machines use to understand our language. Let's look at a quick example. A simple sentence. The future of AI is amazing. To an AI, that gets broken down into this list of 7 distinct tokens. You can see each word is its own piece, and hey, look, even the period at the end gets its own token. This process is called tokenization, and it's the absolute first thing that has to happen for any language model to work.
And this right here is where the magic starts to happen. From these simple little bricks, the AI begins to build meaning. It analyzes billions, and I mean billions, of examples of how these tokens are arranged in human language. And from that, it starts to learn context, the relationships between words, and eventually the intent behind them. It's not just seeing words anymore. It's learning the very architecture of language itself.
Now here's the crucial part. This one fundamental ability, understanding tokens, is what unlocks all the incredible things we see AI do every day. Think about it. Translating languages? That's just mapping the tokens from one language to another while keeping the context. Summarizing a huge document? That's about finding the most important tokens and how they relate. Every single powerful feature, from writing a simple email to drafting a complex legal document, all of it starts with this simple, elegant idea of a token.
Okay, so we have our bricks, the tokens. But a big pile of bricks doesn't make a house, does it? Nope. You need a blueprint. For an AI, that blueprint is made of patterns. This is the next level of intelligence, where the system starts to see the structure and the meaning hidden inside all that data. This quote really gets right to the heart of it. If there's one secret sauce to AI's power, it's this. At its very core, modern AI is the most sophisticated pattern recognition machine that humanity has ever built. And we're not just talking about seeing simple patterns. We're talking about seeing patterns within patterns on a scale that is just completely beyond what a human mind can comprehend. And you could really see the difference in scale right here. You know, we humans, we're pretty good at spotting patterns, but we have our limits. We get tired, our memory isn't perfect, we tend to miss the subtle little details. In AI, it never gets tired. It has a practically infinite memory, and it can spot tiny micropatterns across billions of examples, patterns that are totally invisible to the human eye. So what does this superhuman pattern recognition actually let us do? Well, we're talking about game-changing breakthroughs. An AI can look at a medical scan and detect the faint, early patterns of cancer that even a trained radiologist might miss. It can study centuries of chess games and discover brilliant new strategies that grandmasters had never even thought of. It can sift through millions of financial transactions to find the nearly invisible patterns of fraud. This isn't just a small improvement, it is a total paradigm shift. All right, so we have our bricks, the tokens, and we have our blueprint, the patterns. Now, it's time for the construction. This is where AI starts to reason. It takes all those raw materials in the plan, and it starts to build something logical and coherent.
A really key technique here is something called chain of thought reasoning, and this is a huge leap forward. You see, early AI could spot a pattern and give you an answer, but it couldn't tell you how it got that answer. With chain of thought, the AI actually learns to break down a complex problem into a series of smaller, logical steps. It's almost like it's showing its work, creating a clear, transparent path from the question all the way to the solution.
So let's just walk through how this works. First, the AI analyzes the problem to figure out what's really being asked. Then, just like you would with a tough math problem, it breaks that big task down into smaller, manageable steps. After that, it evaluates different paths and possibilities and then generates a logical chain, connecting one step to the next until it arrives at the final answer. And the most impressive part? It can often explain that entire chain of logic back to you. So here's the bottom line on this one. Reasoning is what elevates AI. It's the difference between a simple calculator that can just give you an answer and an intelligent partner that can help you strategize, plan, and solve complex, multi-step problems in fields like science or law or business. It's not just a tool anymore, it's a collaborator. But wait, what about getting better? A great building isn't just built and then left alone forever, right? It's maintained, it's upgraded, it's renovated over time. The exact same thing is true for AI. The final, crucial building block is its ability to learn continuously from experience, to constantly renovate its own understanding of the world. And one of the most powerful ways it does this is through something called reinforcement learning. The idea is actually super intuitive. It's pretty much how we all learn. You try something, you see if it works, and you adjust your approach for the next time. AI does the same thing, just on a massive scale, using a system of digital rewards and penalties to guide its behavior toward the best outcome. This learning loop is beautifully simple. The AI tries an action. It gets feedback, a reward if that was a good action, a penalty if it was a bad one. Based on that feedback, it adjusts its strategy and tries again. Now imagine this loop running not just once or twice, but millions or even billions of times per second. That is how an AI can achieve mastery.
And the results of this are just stunning. This is the very technique that allowed AlphaGo to study the ancient game of Go and not just beat, but utterly dominate the world's best human players with strategies nobody had ever seen before. It's how models like ChatGPT learn from your thumbs up or thumbs down to give you better answers over time. It's how robots learn to walk, and how financial models learn to navigate the chaos of the market.
So through this relentless process of trial, feedback, and adjustment, the AI moves way beyond simple programming. It starts to develop what looks an awful lot like genuine strategy, good judgment, and deep, deep expertise in whatever it's focused on. It's not just following a set of rules anymore. It's learning how to win the game. So let's bring it all back together one last time. We started with the bricks, the tokens, which let the AI understand language. Then, we needed a blueprint, the patterns, which let it recognize key information. That led to the actual construction, the reasoning, which it uses to solve complex problems. And finally, the ongoing renovation, constant learning, which allows it to improve with every single experience. And that leaves us with one final and pretty fascinating question. If a system has all of these building blocks, if it can understand our language, see patterns that we can't, reason its way through problems, and learn from its own mistakes, what is its final form? That's a big question.
How exactly does AI learn? Assalamu alaikum, and a very warm welcome back to Digital Future AI School. It's awesome to have you here. And hey, before we jump in, if you're getting value from what we do, please do me a quick favor. Hit that subscribe button, give this a like, and share it with your friends. It really helps us grow the community. All right, let's get into it. Okay, so let me just start with a question that honestly still blows my mind. How can a machine, a piece of code really, start with absolutely nothing and in a matter of hours become smarter than every single human who has ever mastered a complex game? I mean, we're talking about games that have been studied for centuries. The answer? Well, it's all about how these things learn. And that brings us to our first big idea. This is a game changer, folks. It's a technique that lets AI reach, well, what you can only call a superhuman level of skill. And it's all thanks to something called self-play. So what on earth is self-play? Well, the core idea is actually pretty simple, which is kind of wild. Imagine an AI that's its own coach, its own rival, and its own trainee, all at the same time. It just plays against itself, again and again and again. That's it. That's the secret sauce. But here's where it gets truly mind-bending. This isn't just a few practice rounds. We're talking about a relentless loop. The AI plays against a clone of itself, and then it does that millions upon millions of times. With every single game, it gets a tiny bit smarter, tweaking its approach. And over all those games, something incredible happens. It doesn't just master the game as we know it, it starts discovering completely new strategies, moves that no human has ever thought of in thousands of years.
And listen, this isn't just theory, this is real. The poster child for this is DeepMind's AlphaZero. Using nothing but self-play, it absolutely dominated 3 of the most complex games humans have ever invented: chess, shogi, and Go. And just to put Go in perspective for you, it has more possible moves than there are atoms in the entire universe. Yeah, let that sink in.
This right here shows you the incredible shift we're living through. On one hand, you have literally centuries of human knowledge, every book, every strategy, every brilliant idea from every grandmaster. And on the other, an AI that blew past all of it in a single afternoon. This is so much bigger than just games, you guys. This is a brand new engine for discovery. What happens when you point this kind of learning at drug discovery or finding new materials? The possibilities are just staggering. So here's the bottom line, the really crucial takeaway. The AI isn't just memorizing what we taught it. It's not a parrot. With self-play, it's actually going into uncharted territory. It's discovering things we never knew. It's creating knowledge that is totally alien to human experience. And that is a tool that can help us see beyond our own limits. Okay, so self-play is amazing for games, right? They have clear rules, a clear winner and loser. But what about the real world? It's messy, it's unpredictable. How does an AI learn to handle that? Well, that leads us to the next piece of the puzzle, something called world models. So what in the world is a world model? Think of it like this. It's the AI's imagination. Seriously, it's an internal simulation of the world that it builds inside its own digital mind. It's like a little sandbox where it can play around, test things out, and most importantly, predict what's going to happen next. If I do this, then that will probably happen. And having this imagination is a total game changer. The AI can run millions of what-if scenarios in its head in a fraction of a second. It can predict what's going to happen. It can try out different ideas without any real-world consequences. Basically, it's building its own mental map of how the world works, understanding cause and effect on a really deep level. And the result of all this? It's huge. This is the bridge that takes an AI from just spotting patterns to actually planning. It's what allows it to go from doing a single, simple task to tackling complex, multi-step goals all by itself. This, right here, is the dawn of real autonomous reasoning. So what can this actually do in the real world? Well, think about an AI agent that can plan and carry out a whole series of steps. Like, you tell it to book me a flight to London next week. And it doesn't just find a flight. It navigates the website, finds one that fits your budget, avoids that airport you hate, and puts it right in your calendar. Or it could read your emails, figure out you need to schedule a meeting, and then coordinate with 5 different people to find a time that works. We're talking about automating really complex stuff. And make no mistake, this isn't just some neat little feature. This is the bedrock. World models are the absolute foundation for building truly smart, truly autonomous AI agents.
This is the leap from a simple tool that just follows orders to an agent that actually understands and reasons about the world it's in. So let's recap for a second. We've got self-play, which lets AI discover things humans never could. And we've got world models, which give AI a form of imagination to understand reality. Now, what happens when you put it all together? You get a revolution, a genuine learning revolution that's creating a whole new kind of intelligence. Just look at the incredible toolbox these systems have now. Yeah, they still do the stuff we're used to, guzzling down data, spotting patterns, making predictions, learning from feedback. But now they can reason logically, step by step. They can practice until they're perfect with self-play, and they can build their own understanding of reality. It's this 1-2 punch of seeing the world and thinking about it that is so incredibly powerful and new. And this really says it all. Think about the things that used to be uniquely human. Stuff that took years of study, deep expertise, complex reasoning, a massive memory. All of those boxes are now being checked by AI. This isn't just about making one task faster. This is changing what it even means to be an expert. And this is not just happening in some lab somewhere. This is already out in the world, changing everything. It's reshaping how we work, how businesses operate, how we educate our kids. It's finding new medicines, making our legal system more efficient. This learning revolution, it's the engine that's going to be driving our society for decades to come. So we're back where we started, but now we know the how. We know how a machine can become superhuman. But that just opens up a much, much bigger question, doesn't it? If AI can already discover knowledge that is totally new to humanity, what's next? What problems that we think are impossible today, in medicine, in physics, in just about everything, what will AI discover tomorrow? And that is the question I want to leave you with.